Hello everyone. Today I will show the solutions to the Prairie Math League High School Round 137 problems 5 and 6. So for problem number 5, Tom possesses a pentagon that has 5 sides of varying lengths. His intention is to paint each side with one of 3 colors, red, yellow, or blue, but no two neighboring sides can have the same color. How many distinct ways can Tom color his pentagon? So for this problem, the fact that it has 5 sides of varying lengths suggests that we don't have to worry about reflection or rotation. So we can just pick an arbitrary side and number them from there. So let's label 1, 2, 3, 4, and 5. So first we have 3 colors to choose for side 1. So without loss of generality, let this just be red, and this won't affect the final answer. Now this one, we just let this be blue. There's 2 ways because we already have 1 way here and we can't choose the same color. So now we do casework on this color of this because this, believe it or not, this color actually matters when determining the other colors. So case 1, this is red, side 3 is red, and case 2, side 3 is yellow. So if this is red, then neither 4 or 5 can be red because they're both next to red edges. And they can't have the same color. So they must be blue and yellow in some order. So either this is blue and this is yellow, or this is yellow and this is blue. And this gives us 2 ways in this case. Now for other option, 3 is yellow. In other words, the color of 3 is not equal to the color of 1. Then notice that either of these can be blue, but both of them can't be blue. And we can swap out number 4 with red and number 5 with blue. Also, notice that in this case, they can both be swapped out. So either we have, let's see, red, blue, red, yellow, or blue, yellow. So that gives us 3 ways for this case. And for our final count, we have 3 times 2 from this and this, and then 2 plus 3 from the casework to get 30 ways. And so the answer is D. For problem number 6, we have an ant with 6 legs, each of which is a different color. And we have a sock and a shoe for each of these colors, and the sock has to go before the shoe. Sorry. The sock must go on before the shoe on each leg. So now we scroll down and see that we can have a task list because ultimately Andy has to have 12 tasks of putting on a sock or a shoe. So now we've tried to count the number of ways for each for the entire task list of 12 tasks. So we consider the legs 1 by 1, and again we number them 1 to 6. So for the first leg, we have to put on the sock at some point and put on the shoe at some point. So this is basically equivalent to selecting 2 tasks in the task list, like this and this. And in this case, we would only have 12 choose 2, not 12 permutation 2, because we have to put the sock on before the shoe, and that's already determined by the ordering of the tasks in the sequence. So now we have for leg 1, we already have reserved spots. Now for the second leg, we again reserve some other spots, and again this time we only have 10 tasks from the task list because we already chose 2 of them. So and 12 minus 2 is 10. But again we choose 2, and these 2 tasks by order can be assigned to putting on the sock and putting on the shoe. And we continue like this. Now we have 8 left, and we just choose 2. So 8 choose 2, etc. And we can continue on like this. Sorry for the texturing scheme, but... And at some point we have 2 left, and we just have to choose 2. So, spirals, I guess. This gives us a total of 12 choose 2 times 10 choose 2 times 8 choose 2, etc. to get a total of 7,484,000, which is option choice C. And we're done. Thank you for watching.